Welcome to a lesson with Dr. Powell. Let's take a look at finding the zeros of this polynomial, so the solutions of this, by using our polynomial factorization technique. First, we come up with a list of potential zeros. So factors of this over factors of this. So factors of this are just 1, so plus or minus. So these are options, but then you need to take this over factors of 2. Well, factors of 2 are 1 and 2 plus or minus. So looking at that, we can, if we divided everything by 1 plus or minus, then this would just simply still be plus or minus 1. Divide all this by 2 though, then we could add to our list. So we know we could have positive a half and positive 1. We could also have negative a half and negative 1. That's our full list of potentials to try. So let's just go for it and see how it goes. All right. Well, and maybe we should double check to see kind of what our zeros really look like if we have positives or negatives. So it looks like we have one sign change, so we're guaranteed a positive 0. So really should, maybe go to the positives. So positive 0. I mean, just out of curiosity, we can kind of think about the negatives for a minute. So if we plug in a negative x in everywhere, we'd have a negative, positive, and that would become a positive, negative. Looks like we have 2 sign changes, which means that it is possible that we could have 2. So only one positive 0, but it looks like that we could have 2 potential negative zeros because we have 2 sign changes, but we also might have none. That's because we can go 2 or an even number less, and so you can get 2 minus 2 would be 0. So it's either 0 or 2 negatives. Okay, so we know that much. Okay, so we know that there's 1 positive 0 and then there's 0 or 2 negative zeros. All right, just keeping that in mind. Maybe we could have just tried all that as we were talking, but just illustrating the different types of checks that we have, though. So next, let's consider taking and trying out maybe a negative a half. Let's just try that one. Okay, so let's just try a negative a half and see how it goes. Now, you might shy away from trying a fraction, but actually, if it's going to work out, it's going to look nice, because you have to realize you're going to get 0 in the end here. So you're going to be having to multiply by things to get whole numbers as you go. We'll see that as we proceed. Also, remember, for starters, that this thing in the denominator will be a factor of the leading term just by setup for how we chose it. So when we drop this and multiply that, I mean, we're automatically getting a whole number anyway. And as we proceed, we'll notice that we end up getting whole numbers if it really does work out. If it doesn't seem to give us whole numbers, let's just skip it and kind of go on to something else. All right, so trying this, we bring down the 2, multiply negative a half times 2, and we get negative 1, we get 0, we get 0, we get negative 2, and multiply it, we get positive 1. Oh, voila, we did get 0. Okay, so let's see how this factors. This means that our divisor here is x plus a half. So we get a x plus a half multiplied by, right here, looks like it's 2x squared minus 2. Now, you see this 1/2 in here. It would be nice if we could multiply this whole entire factor by 2, which we can, because look, we have an extra 2 multiplied in here. What if we factor 2 out of this guy? Like that. And see this, then this 2 is hanging out now, right outside this factor, and it can distribute in across the addition. So the 2 distributes in and we get 2x plus 1, x squared minus 1. And so we've successfully factored this like this. And notice that this is a difference of 2 squares right here. So that'll factor as x plus 1, x minus 1, and then we have 2x plus 1. So we get our solutions as being x equals, looks like -1/2, and -1 and 1. Okay, so notice how just knowing one solution and doing this synthetic division gives us a factorization, and then from that factorization we can wrap it up and finish it up to see exactly what the solutions would be when we set this equal to 0. So in this particular case we get 3 different solutions. They all have multiplicity 1. And notice how we did this right here. We had x plus 1/2. We didn't like that half there, so we pulled something. We factored another one of the factors, like this one, out by 2, and then stuck the 2 instead into this guy, and we got rid of that. Another way of thinking about that is you could actually see it from right here. 2 is a factor of the leading coefficient, so it'll also be, actually it corresponds to this guy right here. And then see this -1, change the sign and put a +1 here and put an x there. So that's another way of thinking about how you can get this factor based upon that. Thanks for watching.